Hello everybody and welcome to review 3. So today we're going to be talking about gravity, Coulombs Law, and electrical circuits. And so let's get started. So we're going to start off with gravity. And so remember that space is kind of like a fabric. And so what that means is like more massive objects or objects that have more mass are going to leave a larger indent on this fabric. And so things are going to be more attracted to that larger mass. So keep that in mind as we go. But Newton's discovery, so remember Galileo discovered inertia. And so what inertia is like the resistance for an object to change its motion. If it's in a certain state of motion, it wants to stay in that motion. And so moving objects move at a constant speed in a straight line if there's nothing else acting on them. All right, there's no other forces. If an object undergoes a change in speed or in direction, then a force is responsible for that change in speed or direction. And so Newton theorized that the moon had to be falling towards the Earth, and it had to have enough tangential velocity in order to avoid hitting the Earth, or meaning that the moon needed its own type of velocity in order to, not come crashing or barreling towards the Earth. And if it had more speed than what it actually was, then it would continue off into space. So using the ideas of a cannonball, Newton compared the moon to the motion of a cannonball being fired from the top of a mountain. And so if we give the cannonball enough horizontal velocity, it's going to carry on in that parabolic path, or it's going to carry around in that orbit. Okay, so if it's not enough horizontal velocity, then it's going to fall down the parabolic path. If it is enough, then it's going to continue in that shape around that object. In this case, it's going to continue in an orbit. And so therefore, Earth was not the center of the universe. So if we compare the masses of the cannonball to the mass of the Earth, we know that, the Earth had a larger mass than that cannonball, and so that gravitational pull was stronger. But with the ideas of the sun and the Earth, Newton discovered, there was this idea that Earth was not the center of the universe. So planets fall around the most massive object, the sun. So, in our solar system anyway. So slow the speed of the Earth and we're going to all go crashing towards the sun. And that goes for any planet. If you slow that tangential velocity, then they're going to go crashing towards the sun. And so what is gravity? Well, it's one of the 4 fundamental forces, and it acts as a pull between two masses. And it's actually an incredibly weak force. And so the law of universal of gravitation says that every object attracts other objects. So I'm sitting at my computer right now, and so there's a force of gravity between us. There's this pull between us, but it's so little that we don't even notice it. And so the force is directly proportional to the mass. So what that means is if you increase the mass of those objects, then the force between them is going to increase as well. If you decrease, then the force between them is also going to decrease. And it says that the force is inversely proportional to the square of the distance. So if you bring those masses further apart from one another, then that force is going to decrease. If you bring them closer to one another, then that force is going to increase. And so the universal gravitational constant is called the capital letter G. And basically it represents like the strength of gravity. As we know, gravity is a really weak force. And so G is also going to be on your Mcas formula sheet. It has a value of 6.67 times 10 to the negative 11th Newton meters squared over kilograms squared. And again, it's this numerical relationship between mass, distance, and the force of gravity. So our first Mcas question says, 1 7-kilogram bowling ball is lifted to a storage shelf 1 meter above the floor. A second 7-kilogram bowling ball is lifted to a storage shelf 2 meters above the floor. Which of the following best explains why the measured force of gravity on each ball is nearly identical? So go ahead, try your best on this one. So the answer here is C. So it's the distance of the distance of each ball from Earth's center of mass is almost identical. And so you might be saying, well, it's not, right? There's a storage shelf 1 meter and then 2 meters above. Those are different distances. Yes, but in the relationship to how giant the distance from the center of Earth out is, it doesn't really play a difference. All right, so when we're trying to explain the best example of why the measured force of gravity is nearly identical, again, it's just not enough distance between them. So think back to, the cannonball in the Earth as well. Again, really small mass. And then Earth has a really giant mass. And so what that means is, like, if you have to increase the distance, it has to be a really large distance, like out of our atmosphere, in order for the force of gravity to look like it's, or to be measured differently, I should say. All right, so C is the best answer choice. So the sun's gravitational attraction causes a comet's path to curve as shown in the diagram below. Which of the following statements best explains the fact that the sun does not appear to move due to the comet's gravitational attraction? So the best answer choice here is A. The sun's mass is much greater than the comet's mass. So as we know, everything is going to be more attracted to the object with more mass. And so the sun has more mass than this tiny comet. So we can't really see the gravitational attraction that the sun also has to the comet. And again, that's just due to the sun's mass being much greater than the comet's mass. So let's talk about gravitational fields. So gravitational fields surround massive bodies. So Earth has a gravitational field. And so if you are a mass within this gravitational field, then you are going to experience a force. So that's why we call it a force field. And so these field lines represent a gravitational pattern. So our field lines basically represent the acceleration due to gravity, g, 10 meters per second squared. And the closer where you are to the field lines, the stronger the force of gravity. Any mass in the field goes towards the direction of those field lines, so towards the center of the object. And so weight and weightlessness, so the force of gravity causes acceleration, and since we're in contact with the Earth, we perceive this force of gravity as a pressing down against us. But in reality, it's trying to accelerate us towards that center of the Earth. But luckily, we have this amazing support force of the Earth's surface that keeps us, on the surface instead of towards the center of the Earth. So the diagram below represents two identical spaceships, Earth, a space station, and the moon. The two ships are launched toward the moon. Ship 1 is launched from Earth, and Ship 2 is launched from the space station. It takes less force to launch Ship 2. Which of the following contributes most to the difference in the forces? So again, thinking back to those gravitational field lines, the closer that you get to them, the stronger that force, the further away, the less strong that force. And so Ship 2 is further away from the Earth. So they're going to experience less of a force of gravity. And so Earth exerts less gravitational force on Ship 2 than on Ship 1. That is the best answer choice here. So which of the following statements best describes the force of Earth's gravity on a rocket moving upward? So the same idea as before with the ships, the further that you get away from the center of that mass, the less strong the force of gravity is going to be. And so as that rocket leaves Earth and gets further and further away, or further into space, the force of gravitation, or the force of gravity, is going to be weaker on that rocket as it gets higher. All right, so let's review some electrostatics. So what we're going to talk about is electric charges, the forces involved, and the behavior within the materials. And we all have to remember the atomic model. So remember, all material is made up of atoms, and within those atoms we have 3 subatomic particles which make up the atom: the proton, the neutron, and the electron. Protons have positive charges, electrons have negative charges, and neutrons have no charge, or they're neutral. And so our atom is made up of a positive nucleus that makes up protons and neutrons within that nucleus. And then on the outside, we have these orbiting electrons. So there's a force of attraction between that positive nucleus and those negative electrons. And so this idea of charge is fundamental. Okay, so what we're looking at is a mutual attraction or repulsion between electrons and protons. And so this is different from our ideas of gravity. So remember that the gravitational force is like an attraction between two masses, where our electrical forces are either an attraction or repulsion depending on the charge. So electrical forces can come from atomic particles. And so again, the fundamental idea or this electric rule is that like charges are going to repel and opposite charges are going to attract. So if you have a positive charge and a positive charge, they're going to repel. If you have a negative charge and a negative charge, they're also going to repel. Neutral is still going to stay neutral. There's no charge going on there, so there's going to be no force of attraction, and they're not going to repel either. And so the unlike charges, a negative charge and a positive charge, are going to attract. And so remember that your atom is always striving to be neutral. It's always striving to have no net charge. So what that means is it's always striving to have an equal number of protons to an equal number of electrons. And so when unequal numbers do come about, we call that a charged atom. And that charged atom is called an ion. And so we can have positive ions or we can have negative ions. So a positive ion that has like lost an electron or one or more electrons. And so it's no longer a neutral atom. It now has a more positive charge because it has more protons than it does electrons. And if an atom gains one or more electrons, then it's going to be a negative ion. Again, it's just a charged atom, but now it has more electrons, so it's negatively charged. So electrons exist in different orbits. So we can have like an innermost, which are really strongly attached to that positive nucleus, and those outermost, which are loosely attached to the positive nucleus. So those outermost electrons are the ones that can flow more easily. And so when we're talking about the flow of electrons, we're talking about this movement of charge, but there's also an idea of the conservation of charge, which says that electrons can neither be created nor destroyed. They can only transfer from one atom to another. And so the ways that the charges can transfer is charging by friction, charging by induction, and charging by contact. So if you were to take a balloon and rub it against your hair, that would be a charging by friction. You're charging that object to have either probably more negative charge, because again, it's only electrons moving. You're charging that object to have a charge based off friction. Induction would be bringing like a negative rod or a positive rod towards some type of scope. And again, electrons are going to be transferred there. And charging by contact, you're touching an object that is already charged, and there's a movement or a transfer of electrons. So when we are looking at the force of attraction or repulsion between our charges, we're looking at Coulombs Law, all right? And again, it looks very similar to the force of gravity, but pay attention to one, we're now dealing with charges, and two, we have a different constant, K. But the same type of ideas apply, where the charge values are directly proportional to the force. So if you increase the charge, you're going to increase the force between them. And distance is inversely proportional. So if you increase the distance between your charges, that force is going to decrease, and vice versa. And so again, d is the distance between particles, q1 is charge particle 1, q2 is charge particle 2, and k is the electrical proportionality constant, and it holds a value of 9 times 10 to the 9th Newton meter squared over Coulomb squared. So yeah, remember that one. But when we're looking at, the difference between the force of gravity and the force of this electrical force, I should say, gravity only attracts. It's only a force of attraction between two masses, where our electrical forces can either attract or repel depending on your charge values, right? You can either have a negative, positive, 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 negative. And so that force is going to be different depending on what charge you have. Also, K is a really large value constant. So what that means is that K is going to create this larger electrical force, which means that our electrical forces are stronger than our gravitational forces. So if you think back to what the universal constant of gravitation is, it's really, really small. So with this Mcas question, let's read it out and then try your best. Newton's universal law of gravitation and Coulombs law have similar mathematical relationships as shown. Which of the Okay, so let's look at this Mcas question. Newton's universal law of gravitation and Coulomb's law have similar mathematical relationships as shown below. Which of the following tables correctly identifies whether the force described applies to only Newton's universal law of gravitation or only Coulomb's law or both laws? Okay, so let's go through this one. It's A, and the ones that I found most tricky was part 3 of this question, where it says the force increases if the mass of both objects increases. So remember, it was trying to trip you up. But when it's masses, we're only working with Newton's law of gravitation. And so that automatically cancels out B and C. And so then the force can be attractive for both laws, yes, but the force can be repulsive only for Coulomb's law. So that just leaves part A. But yeah. So our next question says the diagram represents the electric field around a positively charged object and a negatively charged object. 4 locations, W, X, Y, and Z, are labeled in the diagram. At which of the labeled locations would another positively charged object experience the greatest net force? So it is W, but let's discuss Y. So it couldn't be X because that's more towards that positive side. And so there's going to be a force that's going to repel both positive charges. W, because it's very close to that negative, that distance between them, that means that the electrical force is going to be really strong. And also it's attracted to that negative side. So W is your best choice there. So 3 pairs of charges, X, Y, and Z, with different charges are shown. Each pair is separated by a different distance. So we have X, Y, and Z, we have their charge values, and we have the distance between those charges. Which of the following correctly orders the pairs of objects from the least to greatest amount of force between them? So if you forgot about like directly proportional and inversely proportional, you can like absolutely use your equation sheet and do all of these out. But if you remember that as you increase that separation, the electrical force is going to decrease, then this one was like kind of like a yay, I got this one. So the other thing that you need to be aware of is it's asking from least to greatest. So the electrical force that is going to be least is X and greatest is Z. Again, so it has to do with that distance between those two masses of the charges. I should say not masses, two charges. Okay, so we have our charge value, we have that distance in between, so that's going to be a really small distance, so that increases the force. And so A is the answer here. All right, so let's talk about electrical circuits. So again, this is all from the ideas of our electric charges, that our atoms are made up of electrons, protons, and neutrons. They're all striving to have no charge. And so when a new electric charge is presented to the atom is going to try to move it along or pass it along. And so what this passing along is electricity. It's the flow of your electrons or your flow of charge. And so with our ideas of our electric circuits, we have like voltage, we have current, we have resistance. So let's start with voltage. If you ever look on Mcas and see something like this, please know that that is 2 batteries. And as we know, our electrons are our current is going to go from positive to negative. Our electrons are going to go from negative to positive. And when charge difference between 2 points exists, then there is a potential to flow, and what that potential really is voltage. And so you need a potential in order to have electricity. You need a potential in order to have this current. And so your voltage is measured in volts, And again, the potential must exist in order for current to flow. And what current is your flow of electric charge. It's that rate of flow of electric charge, and that is represented with I, and you measure that in amperes or amps. And again, that net charge of the wire, it has to maintain an equal number of protons to an equal number of electrons. Again, we want it to have zero net charge. Voltage and current are related through resistance, okay? And it's all related through Ohm's law, all right? So resistance is represented with R. We measure it in ohms, which is written as like that upside down horseshoe. And so again, Ohm's law is equal to V is equal to IR, but we write it in our triangle so that we can memorize I is equal to V over R and R is equal to V over I. Remember that voltage is the push, all right? Resistance is the opposing to the push, and current is just what occurs. If you ever see this on your Mcas, this represents a switch. When the switch is open, just like this, then the circuit is incomplete and current cannot flow. When the switch is closed, there'll be this side will be circled and darkened, and that shows that the switch is closed, and so that means it's a complete circuit and current can flow through. So the diagram shows a circuit with 4 switches, W, X, Y, and Z. A student wants the largest possible current to pass through location Q when the student closes 2 of the switches. Select 2 switches the student should close. So W is going to give the student the largest possible current because it has the least resistance. And so remember that resistance is like the push back to the flow of charge. It's trying to prevent that flow of charge. So with more resistance, you have less flow of charge. With less resistance, you have more flow of charge. So some of our other simple circuits are series circuits and parallel circuits. So remember in a series circuit, those resistors are all lined up in series. They're all lined up in a row. So you can add those resistors together. And remember that if you were to remove one of those light bulbs from your series circuit, the whole circuit is going to go out because it's an incomplete circuit. In a parallel circuit, there's many paths for your electricity to take. And so what that means is if you were to remove one of those light bulbs, it's not going to break your circuit. The electricity is just going to choose a different path in order to go down. So in a series circuit, your current stays the same. In a parallel circuit, your voltage stays the same. So again, kind of just going on the series circuit, the current stays the same. Remember that charge conservation, you can't create nor destroy electrons, so the current cannot disappear. In a parallel circuit, the potential difference or the voltage is the same all the way across the circuit. So a circuit with 2 resistors and a 12-volt battery has a current of 0.5 amps. Which of the following circuit diagrams could represent this circuit? So what you need to do is use Ohm's law, V is equal to IR, but rearrange so that you can solve for the current, because that is the only thing that we're kind of like, we need to match, you know what I mean? So we have a 12-volt battery, and then we have these resistance, and then we just kind of have to add them together because it's a series circuit, and just use Ohm's law in order to solve for the current. So what that means is in a series circuit, again, the current is all the same, so we don't have to take into account a change in the current. So we solve for our total, so we add up those resistors, so 16 plus 12, or 8 plus 16, or 24 plus 8, or 24 and 24. And then we use Ohm's law again. I is equal to V over R. V is 12 volts, and then whatever your R total is, and then you just work it out for each. So you should get that C is the only one where the current is equal to 0.5 amps. All right, so let's talk about power. So power is equal to IV or VI. You can write them both ways, but basically your voltage times your current. And so it's basically telling you like how much power is in your circuit, and it's measured in watts. So a student creates a circuit with a variable voltage supply and a 2 ohm resistor. The student varies the voltage and measures the current. The graph below shows the student's results, current versus voltage. Current is on your y-axis and voltage is on your x. So go ahead, try to work this one out the best that you can to solve for the power. So the voltage is increasing, right? So we see at 4 volts, the current is at 2 amps. So what we need to do is just use that data. Like that's our highest voltage, that's our highest current. So let's use both of those to solve for the most power. So the greatest power supplied by the battery is going to be 8 watts.